today, what we're going to do is hook up two of these together. That is a Digi XBEE wireless module, and it is plugged into an Adafruit XBEE Shield so that you can hook it up to an Arduino or a computer or some other thing. And the cable that I'm using, it is a TTL 232R-3V3, and it has a built-in FTDI chip. So if you want to wirelessly do things, you need a coordinator and a router or an end remote unit, XBEE. You only need two. One coordinator to send the information and one receiver to receive the information. And the same XBEE does it. Same, you don't have to order anything special. It's order two of the same kind and they talk to one another. So, the first thing you have to do though is you have to get the cable to work with your computer. This particular computer that I have, it uses, it's a Vista machine, so we're plugging in that cable for the first time on this one, and we will see what we have to do to get it to work. And one of the first things you have to do is download the software if the machine does not recognize the cable. And that's what we're waiting for right now, to see if it will recognize the cable. Your device is ready to use. Well, that's interesting. We will have to see. The next thing you have to do is go into the device manager. Okay. And in device manager, you have to make sure that it is properly working. So what we do when it comes up is you go over here to ports, COM and LPT, and open that up, and you can see that the USB cable is connected to the serial port COM6. Kind of have to remember that. COM6. Okay. Next thing you should do is download the software XCtu or x-ctu, and let's go to the internet from Digi, and this is what we're going to use to configure the chip, configure the module, as well as program it. There's several ways of getting the program. We're going to go first to Adafruit's website. First we need the FTDI cable. And what's nice, it automatically gives you a choice in this drop-down menu. So anytime you want to communicate with your XBEE, you need some sort of device, whether it be a cable or you could actually interface it with the Arduino. But that's what the cable looks like. And if we go over here to description, so in the description down here, you'll see this cable is fully compatible with the TTL 232 cable from FTDI. You can download the drivers and the diagram and a spec sheet from the website by clicking on that area. Which brings you here, and we are going to look at and we want the D2XX drivers. So we need the Windows and available as setup. So we're clicking on that. Okay, it finally came up with the program, and I'm just going to run it. So once the drivers are downloaded, you have to extract them to get the download for x-ctu from Digi International. Once we're at the website, you can just download it straight from there, which we're going to do right now. Alrighty, Windows. Do you want to run or save? Well, first we're going to save it, and once it's saved, then we'll run it. Now we're going to run it. Alright. So finally a setup screen comes on. Welcome to the... So we'll see. Okay, there's some information in the Microsoft Word document which would be helpful to you, and also a change log comes up, things that have been changed. These are all coming up automatically, and it tells you remote firmware updates, and that's that when you have yours. And this is the screen for x-ctu. And the first thing we do is we come up here to this plus sign, and it says add a radio module specifying the port. So we're going to click on that once, and it came up with two things on this. And I'm going to try zooming in a little bit so you can see that better. Well, if you're able to read it, you'll notice that it has COM6 for the USB serial port. COM3 is the Toshiba modem, and we are not interested in that part. We're only interested in the serial port, which this XBEE is connected to on the side of the computer. So, at this point, I'm going to put that over here, and we'll just let it dangle here. I don't know if you can see that or not. Anyhow, we have to install radio firmware. see any of that stuff here. So we'll press OK. Oh, we have to select COM6. Okay, and when we select COM6, you'll notice that it's read the baud rate at 9600, data bits 8, parity none, stop bits 1, flow control none, and we don't need to change any of that. So we come down here and we say finish, and what it does is it reads the information off that chip if we're lucky, and we come over here, and when we click on this, the information on the chip will be added to the right side of the screen. Okay, that's good. So in this particular case, the FTDI software that we tried to install way back in the beginning was not necessary because the computer recognized that port. Okay, and it also says updates are available for the software that we downloaded. So we're going to get that and get it updated. I went through this yesterday and it worked just fine on another machine. I decided to use this machine, because it didn't have any of the software in it. So I wanted to start from scratch and show you how to start off with a machine that didn't have anything in it. And I'm taking it through the steps that I had to go through to get it up and running. When I was going through it initially, I had to go to different websites, pull stuff off, go to the YouTube, check videos, see how they did it, and it was just a mishmash, and it took literally 8 hours to get it up and running. I'm trying to do this and save you a whole bunch of trouble. So now that it says review and confirm, finish, we're going to finish. So we're probably going to have to turn this off. It'll probably ask us to, or turn it off by itself. You may come up with a firewall that says it's blocking some information. Just say unblock and it'll finish downloading the update. And then it says you need to restart not the computer, but that software, and we'll restart it. And it comes up with the screen that we need to do our work. Okay, so again, we come over to the left side to the plus sign, because we do have this plugged in. We click on it once. It comes up with the same information we had before. click on COM6 and then finish. It's going to gather information, and once it's through gathering the information, we're going to come over here and we're going to click on this tag, and now it's going to download the information on the right side of the screen. Now this is all in the XBEE that I'm using, and let me first tell you about this tag here on the left. It tells you it's a XBEE, and it tells you the frequency or whatever it's called. It tells you it's an XBEE using 802.15.4. Right below that, it tells you the port it's on, COM6. It tells you the baud rate, the bits, parity, etc. on that line. And underneath that, it gives you the serial number of this XBEE that we're reading right now. Write that down because you will need that later. Okay, over here on the right, we have the product family, which is an XBEE24. It also, again, it's a function set XBEE 802.15.4, and the firmware version is 10ED. That is the latest version. Now, if you need to get a update, it's this chip up here, and it won't let you continue unless you update some of these things. So that takes care of that, because this one is already taken care of and updated. Okay, the first thing we have on this side is CH for channel, and it's on channel C. These are things that are already programmed onto the chip. The next thing we have is an ID, the PAN ID. It comes with a default of 3332. When you're setting your XBEEs up, you want this number to match on both of the XBEEs. I've selected 1208. Your number could be anything else. And when you go to change it, let's just go in here. If I were to change it, let's say I change it to 1209, you'll notice that the bar changed to green. You must write it to the chip before it'll take effect. And it's just that simple. You go over here to where the pencil is on the right side, click on it, and it'll write that one ID, PAN ID, to the chip. If you had changed a whole bunch, then you could hit this other one and it'll refresh the settings on all of them, including the ones you changed. Now I have to change this one back, so we will change it back, and we'll make it 8 again. Save it. Okay, now here's a few other things that you need to do. It records the serial number high, and seeing how the serial number is actually 0013A200, it drops the 2 zeros and starts with 13A200. And the last half of the serial number goes in serial number low, which is 408C4378. And you'll notice it's up here on the left. This particular XBEE I'm using as the coordinator. And when you click the down arrow key, you can have an end device or a coordinator. There is also XBEEs that have router positions. This is not one of them. So this one, when you have coordinator, it's a numeral 1. If you have end device, it's a numeral 0. Okay, scan channels and scan duration. Nothing that I've changed there. Haven't changed any of these. Unless you're familiar with all this stuff, you don't have to do anything with this encryption key, but it does say the value must have at least 32 characters. Well, we don't have 32 characters, and we're not using that anyhow. Okay, again, serial interfacing. You may change this information as far as the baud rate, whether there's parity, and timeout, and enable. So one of the things we did change to get this to work in the way that we're using it is we put API enabled. And you have 3 choices: API disabled, API enabled, and API enabled with PPP, and we are using it enabled. Initially it was on disabled. So that's one of the things you need to change for this particular XBEE to work. And that's really it for this particular one. So, API enabled, that we need. We also need coordinator enabled. Okay. This needs to be coordinator. And the pan ID. So we're changing the pan ID and the CE for coordinator enabled. And we're also doing API enabled. That's it. So we changed 3 things. You may have to add SH or SL. Okay. You will notice that this XBEE, the green LED is flashing approximately once every second. That indicates it's the coordinator. The red doesn't come on unless it's sending or receiving information. The red LED. This XBEE, you'll notice the green LED is flashing about 2 times every second. That indicates that it's an end remote unit. So we have to program that unit as well. So to do that, I'm going to take it out of this circuit that I have it in. I'm going to remove the coordinator and put the end unit on here. Okay. And you can disregard the red wire because that was used for another experiment, but we are using the black wire, and that black wire is connected to oh wait a minute, it's A01. That's where it's connected. Okay, so I need to X this one out, and I need to go up here on the left side to the plus symbol and add device, and again it's on COM6, and it gives you the baud rate, data bits, parity, stop bits, flow control. Nothing changed there. Same as the other one. In fact, they have to match. Then we'll finish. It's reading the information. So now we go over here to this new label, which now lists this XBEE with its serial number underneath here. You can see 0013A200, just like the other one, and then 408C44A7. And if we click on this label, it will now transfer the information that's in this chip over here to the right side. We have the PAN ID, which is 1208, which is the same as we set on the other one. But in this one, our destination address is high at 13A200, and the destination address low is the serial number from the other XBEE, 408C4378. Down below here we have the serial number high and the serial number low, which is the serial number for this chip. We have this one programmed as a end device. We don't have to worry about this encryption thing. And this one has the API enabled with PPP. Is the DIO1 configuration set to low. That other one, D4, which is DI04, is the red wire that's on here, which we are not using at this time. The D1, DIO1, I have soldered onto the board in the second hole here on the back, and right next to that is D01 or A01, and right next to that is A01. Okay. The D1, which is DIO1 configuration, to DO low, which is the number 4. Disregard D4. AP enabled. The PAN ID to to match the coordinator, XBEE. The destination address high, which is part of the serial number, minus the 2 zeros in the front, 13A200, and the destination address low, which is 408C4378, which that's my serial number, so it won't help you if you put that in. Okay, so now we're going to remove this. And we're going to put the other one back on, the coordinator back on. Okay, so it's set, and it's right here at the computer. We've added the shield and the XBEE to breakout board. We have this red wire coming from the 5-volt supply. We have this red wire going to ground. This wire does nothing. We have the black wire from D01 going to the positive side of an LED. Then we have a blue wire going from the negative side of the LED to ground. We have a 5-volt power supply that's connected to the breakout board, and that gives the power to the shield. And this is not connected to any computer or anything else. It's just a 9-volt wall wart. So we're going to place that here, and then we are going to control that LED from our computer over here. So let's go back to the computer. Now the next thing we have to do is program this computer so that it'll talk. And there's another thing we can do. This will show us the network. So if I press that, and then come over here and press this. So now, again, now that I've redid it, we now have our coordinator here, and this is our end unit, our end remote unit, which is over on the breakout board. Again, here's our coordinator. You can see the LED flashing once every second. And I'll do the other one in a minute. Okay, so now that we've got that, we have to turn on the terminal. So here's the terminal. But we have to create a frame. Tell it to do one thing, the other frame's going to tell it to do something else. So, okay, one of the first things you want to do is to open a new frame. And in the frame, you have to give it a name. So it could be high, low, in between. We're going to use in between. And then we create a frame, now that we gave it a name. And here's what you get. You get the protocol, that's our 802.15.4, and we get the frame type. And we're going to do this, and there's several frame types. We have receive, AT command response, remote AT command, and all those. So you select one, And then you have to put in the information that you want. And it has to be in either ASCII or hex. So you can select ASCII or you can select hex. And then you have to do the rest. But we're going to just X out of this one because I already created two. And we're going to X out of this one. Okay, so if I select this frame and then edit, this is what is in the frame. So here's what we have. We have protocol all. And it starts, the frame type always starts with an 017 remote AT command. Then we have the start delimiter, which is 7E. The length is 00 space 10. The frame type is 17. Frame ID is 01. The 16-bit destination address, and that is the serial number for the remote. I think it's the remote unit. 44A7 is the remote unit, the last four. And then we have our FE doesn't change. Remote command options 02 doesn't change. And you put in this D1 is the location that we're going to do something to. And if you look down here, all these things are coming in order the way they are coming down this page. Okay, so when you've put all those in, then you hit OK, and you apply the changes. And then you create the frame, and then you put the information in, then you click OK, and go from there. Okay, so let me get out of here. So once this is in, you connect. Go up here to this button and connect. It'll say API console status connected. It automatically sends information every so many milliseconds, and it receives a answer back every so often, but we haven't sent anything. And if you'll notice, and I'm going to pull back on this. Let's see, can I do that? No, I'm going to grab this. Okay. And I don't know if you can see that or not, but we'll pull back just a little bit. Back. Back. You can see on the bottom the LED flashing twice a second, plus a red light came on, because it did read some information. Now this one in my left hand is connected to the computer, and it is flashing 1 time a second, meaning it's the coordinator. And what I'm going to do is, and I have to move this out of the way a bit, is come over here and say send selected frame. And you'll notice the LED lit up, the blue one. See? Our blue LED lit up. Then if I select the other frame and come over here and put send selected frame, you'll notice the LED went off. So we know it is working wirelessly. And that's the whole object of this, is getting it to take commands and have it do something. And in this case, we had it turn on and off that LED with these packets. Now, of course, this is great for development. What we really want to do is we want to be able to do this using an Arduino. Having this plugged into an Arduino, having this plugged into an Arduino, and then having that Arduino control several things. So hopefully in my next video we will do just that. So nice talking to you guys. I hope this is helpful, and talk to you next time. Bye.